Division of polynomial functions, section 3.2. So I'm going to give you a little bit of an introduction with real numbers. So what I'm about to tell you, you might want to write at the very top above the title here, or write it on the back, right, which is completely blank. Okay. So I have the improper fraction, 107 over 3, okay? 107/3, that's an improper fraction. The numerator exceeds the denominator. And you know fraction bars are like division symbols. So this can be written as 107 divided by 3. And so let's divide 107 by 3 using long division. I'm assuming that everybody got exposed to long division probably in grade school somewhere. Here we have 107. This is the division symbol, and we're going to divide it by the number 3. Okay. Now, 3 doesn't go into 1, or 3 goes into 1 0 times, but 3 goes into 10 3 times. So put 3 in here up the top, and then you go 3 times 3, you get 9. Subtract 9 from 10, you get 1. And then you bring down the 7. And now 3 goes into 17 5 times. Put 5 up there. 5 times 3 is 15. And 15 from 17, 17 minus 15 is equal to 2. Does anybody have a faint remember seeing this somewhere in grade school once upon a time? Right? Okay. So the 107 that's being divided, right, is called the dividend. The 3 is the divisor. The 35 is the quotient, and 2 is the remainder. Okay? So what we have shown is 107/3 can be written as the quotient 35 plus the remainder 2 over the divisor 3. So 107/3 is equal to 35 plus 2/3, which is kind of where you get the mixed numbers from, right? You all have worked in high school, worked a lot with mixed numbers, right? But when we get to college, we prefer improper fractions to mixed numbers because it's hard to multiply, divide, and subtract mixed numbers. Okay, you can multiply and divide fractions much easier than mixed numbers. Okay. All right. Now, if I multiply both sides by 3, I have 107 is equal to 3 times 35 plus 2. So the dividend, 107, is equal to the divisor, 3, times the quotient, 35, plus the remainder, 2. Okay? So this is an illustration with real numbers, what they're talking about here. That's top of page 1 with the division algorithm, which involves dividing one polynomial by another polynomial. So the dividend, f of x, right? The dividend, instead of just being a real number, is now a function of x. divisor is a function of x, the quotient's a function of x, and the remainder's a function of x. Okay? So we demonstrated with real numbers what they're talking about here in dividing two polynomials, right? Each are a function of x. So let's divide two polynomials, right, using long division. Down here in example 1. So in A, we have 6x cubed minus 19x squared plus 16x minus 4 over x minus 2, right? So 16x cubed, or this, the numerator is the dividend, x minus 2 is the divisor. So we set it up to divide the numerator by the denominator. We set it up just like we would with real numbers. Here's the division symbol. And under the division symbol, we have 6x cubed minus 19x squared plus 16x minus 4. And that's being divided by x minus 2. Okay? So again, x minus 2 is the divisor, it's a function of x. And what's under the division symbol is the dividend. It's a function of x. Okay? So this is the x minus 2 is the divisor d of x from our notes over here. Okay? It's d, x minus 2 is the divisor d of x, and f of x, right? This is our dividend, f of x. All right, so what goes up here is the quotient q of x, and what's left over will be the remainder, okay? All right. So we have 6x cubed. Question is, how many times does x go into 6x cubed? Well, 6x cubed over x, that tells you how many times x goes into 6x cubed. Using the rules of exponents, x cubed over x is x squared. So x goes into 6x cubed 6x squared times. So we put 6x squared up here. And then just like with real numbers, you now have to multiply 6x squared times x minus 2. Put the result down here and then subtract. Okay? So just remember when we did division of 107 by 3, right? First time, right? 3 went into 10 3 times. So then we did 3 times 3 is 9. Then we subtracted 9 from 10 and then brought down to 7, right? So we're going to do the same thing over here. Now we multiply 6x squared times x minus 2. And when you distribute 6x squared inside parentheses, you have 6x squared times x, which is 6x cubed. And then minus 2 times 6x squared is minus 12x squared. And just as we subtracted 9 from 10 over here, now we have to subtract 6x cubed minus 12x squared from 6x cubed minus 19x squared. So that you do the subtraction correctly, you should put parentheses around 6x cubed minus 12x squared, because you got to just change the sign of both of those terms when you subtract. So you'll have 6x cubed minus 6x cubed, which is 0. And you have minus 19x squared plus 12x squared, which is minus 7x squared. And then you bring down the 16x minus 4. Now to carry out this long division, you got to ask yourself next, how many times does x go into minus 7x squared? Well, minus 7x squared over x simplifies to minus 7x. So we put minus 7x up here after the 6x squared. And now you got to multiply minus 7x times x minus 2. Minus 7x times x minus 2. You got to distribute the minus 7x inside the parentheses. You have minus 7x squared plus 14x. And now you got to subtract minus 7x squared plus 14x from up above here. So put it in parentheses and a minus sign up front. So you distribute the minus sign correctly. And so you have minus 7x squared plus 7x squared, which is 0, and 16x minus 14x, which is 2x. And then you bring down the minus 4. Now you got to ask yourself, how many times does x go into 2x? Well, 2x over x is equal to 2. So x goes into 2x 2 times, so you put plus 2 up here. And now you got to multiply 2 times x minus 2. And when you multiply that, distribute 2, you get 2x minus 4. And that you have to subtract from 2x minus 4. Well, 2x minus 4 minus itself is 0. Okay. So the remainder, r of x for this problem, is equal to 0, right? There's no remainder. What's the quotient? 6x squared minus 7x plus 2. Right, that's the quotient q of x for this problem. Okay? So, what we have shown is this polynomial divided by this polynomial is equal to 6x squared minus 7x plus 2. Okay. And what we have also shown, if I multiply both sides of this equality by x minus 2, we have shown that the dividend 6x cubed minus 19x squared plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2. Okay. So since there's no remainder, we've shown that x minus 2 is a factor of this polynomial. 6x cubed, right? X minus 2 is a factor of 6x cubed minus 19x squared plus 16x minus 4. Okay? Any questions on that? Long division. Fun stuff, isn't it? Yeah. All right. No questions? So let's take a look at B I'm not gonna do the long division, but I'll set it up for you and then you verify my answer. In B, we have x cubed minus 1 over x minus 1. So, to set it up, right, x cubed minus 1 is the divisor, or is the dividend, and x minus 1 is the divisor. Now you notice, right, there's no x squared or x term, so you gotta make room. So I would set it up this way. Leave spaces for x squared and x, okay? And then when you do the long division for quotient, you should end up with x squared plus x plus 1, okay? So you verify that that's the correct quotient using long division on your own, okay? All right, any questions? All right, let's take a look at C, where we're dividing 2x to the 5th plus 4x cubed minus 5x squared plus 3x minus 2 over x squared minus 3. Okay? Are you with? Is everything okay?
I don't understand B.
What about it?
Like the open spots. Like
Well, there's no x squared or x term.
So you just put like.
So you can x cubed plus 0 times x squared plus 0 times x minus 1.
Okay.
That's why I put the spaces there. Okay? All right. Any other questions? All right. So this one looks a little bit more challenging. So our divisor is x squared minus 3. Then we have, for our dividend, we have 2x to the 5th. And you'll notice there's no x to the 4th term. So I left a space, right? It's actually 0 times x to the 4th. Okay. And then we have plus 4x cubed minus 5x squared plus 3x minus 2. So x squared minus 3 is our divisor in this problem. And 2x to the 5th plus 4x cubed minus 5x squared plus 3x minus 2 is our dividend. Okay. All right. So do long division. You got first step. How many times is x squared going to 2x to the 5th? Well, 2x to the 5th over x squared is equal to 2x cubed. We put 2x cubed up there. And now you got to do 2x cubed times x squared minus 3. Right, so you got to distribute the 2x cubed, and you get 2x to the 5th minus 6x cubed. Maybe I didn't have to put a space there. Okay. Because there's no x to the 4th term that creeps in. Okay. I thought there might be, but there isn't. Okay. So I didn't actually have to put a space there. And so now we subtract 2x to the fifth minus 6x cubed from up above. 2x to the fifth minus 2x to the fifth is 0. 4x cubed plus 6x cubed is 10x cubed. We bring down the minus 5x squared plus 3x minus 2. And then you gotta ask yourself, how many times does x squared go into 10x cubed? So we have 10x cubed divided by x squared, which is equal to 10x. So x squared goes into 10x cubed 10x times. So we have plus 10x in the quotient. Now you gotta take 10x times the divisor, x squared minus 3. And when you distribute the 10x inside the parentheses, you end up with 10x cubed minus 30x. You gotta subtract that from up above. 10x cubed minus 10x cubed is 0. Minus 5x squared minus 0 is minus 5x squared. And then 3x plus 30x is 33x. And you bring down the minus 2. Now you gotta ask yourself, how many times is x squared going to minus 5x squared? Can you answer that? Minus 5x squared divided by x squared is minus 5 times. Well, minus 5 times x squared minus 3 is minus 5x squared plus 15. So you subtract that from up above. Minus 5x squared plus 5x squared is 0. 33x minus 0 is 33x. And minus 2 minus 15 is minus 17. And x squared goes into 33x 0 times. So yes, sir.
So why did you skip the negative 5x squared?
Where?
Top.
Up here?
No, down. Yeah, right there.
What do you mean skip it?
Like, did you?
Minus 5x squared minus 0 is minus 5x squared.
So wait, where'd you get the 0 from?
Well, there's nothing there. When I multiply 10x times x squared minus 3, I get 10x cubed minus 30x.
Oh, okay.
There's no x squared term when you do that multiplication. Okay. Any other questions? Okay. So this is our quotient. And this is our remainder. So, we have shown that 2x to the fifth plus 4x cubed minus 5x squared plus 3x minus 2 divided by x squared minus 3 is equal to the quotient 2x cubed plus 10x minus 5 plus the remainder, 33x minus 17, over the divisor, x squared minus 3. So x squared minus 3 is not a factor of this polynomial in the numerator, because it has a remainder. And if we multiply both sides of this equality by x squared minus 3, we get the dividend 2x to the 5th plus 4x cubed minus 5x squared plus 3x minus 2 is equal to the divisor, x squared minus 3, times the quotient, 2x cubed plus 10x minus 5, plus the remainder, 33x minus 17. Okay? Any questions on that, ladies and gentlemen? All right, so if you flip over to page 2, talks about the remainder theorem, and there's a little bit of a error on this, okay? So it says if a polynomial f of x is divided by a linear polynomial, instead of saying x equals c, that should be x minus c. Okay? So if a polynomial f of x is divided by a linear polynomial x minus c, then the remainder r is the value of the function f of x at x equals c. That is, f of c is equal to r. Okay? So let me show you this in equation form. So we have, and we have the polynomial or the dividend f of x is equal to the divisor x minus c times its quotient q of x. And because x minus c is linear, the remainder r is not a function of x, it's just a real number. Okay.
Can you explain that again?
What's that?
Can you just say that again, like?
The dividend f of x is equal to the divisor x minus c times its quotient q of x plus the remainder r. But r is not a function of x because the divisor is raised to the first power. So the remainder is always 1 power less than the divisor. The divisor is a first degree polynomial, so the remainder r is a 0 degree polynomial. It's just a real number. Okay? This is a real number. Okay? And so if we evaluate this polynomial x equals c, we have f of c is equal to c minus c, right? Put it in c and for x on the right hand side. And so we have c minus c times q of c plus r. Well, in parentheses, c minus c is 0, and 0 times q of c is 0, right? So we have f of c is equal to 0 times q of c plus r, or f of c is equal to r. That's what the remainder theorem is saying right here. Okay? So, in a nutshell, what the remainder theorem is saying is we don't have to do long division the remainder R. Okay? When the divisor, okay, is linear, x minus c, we don't have to do long division to find the remainder. You just evaluate the function at x equals c. Yes, ma'am?
Is that Q a different Q than the first page?
Well, this is the quotient.
Okay.
This is quotient for this dividend. So on the first page, right, f of x is the dividend. And q of x is the quotient. And x minus c is the divisor. And r is the remainder. Okay? So it's a special case of the first page. Okay?
Oh, sorry.
When this is linear, when the divisor is x minus c.
Capital and lowercase.
Say what? Oh, you know what? Thank you. Thank you. It is supposed to be a small q. Yeah. Thank you. Some books it's a capital Q. In our book, it's a little q. Yeah, thank you for pointing that out. Okay? Yeah, I want to be consistent with the text. Okay? All right? With page 1. All right. So, in example 3, it says use the remainder theorem to find the remainder when f of x is divided by x minus 3. Okay? Well, we don't have to do the long division to find that remainder. We can just use the remainder theorem. You could use long division to find the remainder if you wanted to, but you don't have to. Okay? So, the divisor is x minus 3. So c in this case is equal to plus 3. Okay? Remember, we're dividing x minus 3. Right? This theorem applies when you divide by x minus c. And so c in this case is equal to 3. So to find the remainder when you divide f of x by x minus 3, you just evaluate the function at x equals 3. Okay? And that tells you what the remainder would be if you did the long division. And so f of 3 in this case is equal to 2 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 6. And when you do the arithmetic, PEMDAS, you should get 15 is the remainder. Okay? So the remainder, if you divided f of x by x minus 3 using long division, you'd have a remainder of 15. Okay? You don't actually have to do the long division. In example 4, use the remainder theorem to find f of c for f of x when c is equal to 1/2. So again, okay, you could divide f of x by x minus 1/2 with long division to find the remainder, or you can just use the remainder theorem. And the remainder theorem says if you divided that function by x minus 1/2, the remainder would be f of 1/2, the value of f of 1/2. Well, f of 1/2 is equal to 3 times 1/2 to the 4th minus 5 times 1/2 squared plus 2. And using PEMDAS, right, you get 3/16 minus 5/4 plus 2, which is equal to find common denominator is equal to 15/16. Get something different, let me know. Okay. So this is the remainder R that you would get if you divided this function using long division by x minus 1/2. All right, any questions on that? All right, synthetic division. How many of you were exposed to synthetic division in high school? Okay, so some of you maybe weren't. So we'll try to review it. Your book actually doesn't explain the steps in synthetic division. It just gives examples, using it. And so it assumes that you have some prior exposure to it. Okay. So synthetic division is used to divide polynomials by linear polynomials of the form x minus c. It doesn't work for higher powers, when you divide by higher powers of x. It has to be x to the first power. Okay? So in example 5, we're going to use synthetic division to find the quotient and remainder when f of x is equal to x to the 4th minus 14 x squared. Now, I'm going to point out something. There's no x cubed term. So it's actually 0 times x cubed. Okay? X to the 4th plus 0 times x cubed minus 14x squared plus 5x minus 9. Right? As we set up synthetic division, you got to write up coefficients and descending powers of x. So, starting with the highest power, right? 4, 3, 2, 1, 0. All right. And we're going to divide that polynomial by x plus 4. Well, remember, this is of the form x minus c. So x plus 4 is the same as x minus a negative 4. So c is equal to negative 4 in this case. So negative 4 goes in a little box all by itself on the upper left. And then you write out the coefficients of the polynomial that's being divided. So the coefficient for x to the 4th is 1. Coefficient for x cubed is 0. Coefficient for x squared is minus 14. Coefficient for 5x is 5. And the coefficient for the constant term is minus 9. Okay? And then leave a space and draw a horizontal line. Okay? So the first step in doing synthetic division is to bring down the first coefficient below the line, which is 1. So we bring down the 1, okay? And then we multiply the 1 by negative 4. So minus 4 times 1, which is negative 4, and that goes in under the 0 in the second column. So we minus 4 times 1, which is negative 4. And then you add negative 4 to 0, and you get negative 4. And then you multiply this negative 4 by this negative 4, and you get 16, and that goes in the next column. Then you add negative 14 and 16, get 2, right? so the only two mathematical operations that we're doing here is multiplication and addition. That's the only two operations you use. Alright, so minus 14 plus 16 right, is 2. Now I'm going to stop writing down the steps. Right, and you just keep repeating this pattern. Negative 4 times 2 is negative 8. And negative 8 plus 5 is negative 3. Negative 4 times negative 3 is 12. And minus 9 plus 12 is 3. Now you box this last number, because that's the remainder. Okay? So 3 here is equal to R, the remainder, which should be the same as the function evaluated at minus 4. Put in minus 4 up here, and you should get R is equal to 3 from the remainder theorem. Okay? So what do these numbers represent? They're the coefficients for the quotient. Okay? So, starting on the right here, this is the coefficient for x to the 0 power, which is equal to 1, right? So this is just the constant term. This is the coefficient for x. This is the coefficient for x squared. This is the coefficient for x cubed, right? So 0 power, first power, second power, third power. Okay? The increasing powers of x from right to left. So the quotient q of x in this case is equal to 1 times x cubed, which is x cubed, minus 4 times x squared, which is minus 4x squared, 2 times x, which is 2x, and the constant is minus 3 times 1, which is minus 3. Okay? So this is the quotient. When you divide this polynomial by x plus 4, and the remainder R is equal to 3. We're done. Okay? So I'll have to move that homework out. Okay? I wasn't able to accomplish what I thought I might be able to.